You've probably seen classic airliners before, but nothing quite like this. 3 engines, a wide-body fuselage, and a whisper-quiet ride that pilots still rave about.
You're looking at $18 million worth of airplane. It's the Delta TriStar, the newest jet in Delta Airlines' wide-ride fleet.
The Lockheed L-1011 TriStar wasn't just a sleek machine, it was an engineering flex. With advanced avionics, full-capability Autoland, and the pioneering Rolls-Royce RB-211 turbofan, it aimed to be the most sophisticated jetliner of its era. But here's the real question: why did it vanish so quickly? In the 1970s, Lockheed entered the commercial aviation race late. The market was already split between the McDonnell Douglas DC-10 and Boeing's expanding 747 and 727 lines. Still, Lockheed believed there was room for a third contender, a safer, smarter, and smoother trijet. So why did one of America's top defense contractors struggle so badly in the skies? Was it bad luck? Or a perfect storm of overreach, engine delays, and corporate scandal? In this video, we'll break down the rise, fall, and fragile legacy of the L-1011 program. From its high-tech promise and high-profile problems to the airline politics that clipped its wings, we'll explore why the TriStar was both a marvel and a misstep. Because once you see how close it came to changing aviation, you'll understand. The L-1011 wasn't just advanced, it was decades ahead of the competition.
Like to take a tour before the passengers come aboard? The 3 cabins on the TriStar are wider than most living rooms, 19 feet wall to wall.
To the untrained eye, the Lockheed L-1011 TriStar might appear to be just another wide-body trijet from the golden era of jet travel. But for aircraft enthusiasts, the TriStar stands as one of the most technically ambitious, misunderstood, and ultimately tragic aircraft in aviation history. Developed in the late 1960s and entering service in the early 1970s, the L-1011 wasn't just another plane. It was a flying technological showcase. At a glance, the L-1011 competed in the same space as the McDonnell Douglas DC-10 and Boeing's growing fleet of wide bodies. It was a 3-engine aircraft designed for long-haul, high-capacity routes, capable of carrying around 250 to 400 passengers depending on configuration, with a range of about 4,000 nautical miles. But beneath its aluminum skin, it hid a treasure trove of pioneering aviation technology. Unlike its contemporaries, the TriStar featured a revolutionary Autoland system certified for Category 3B landings, meaning it could land itself in near-zero visibility. Pilots described the aircraft as a dream to fly. With one of the smoothest ride qualities of any airliner ever built. Its quiet cabin, made possible by advanced engine design and insulation, became legendary. But what truly makes the L-1011 fascinating is the contradiction it represents. Despite being arguably superior to the DC-10 in nearly every technical metric, better safety systems, quieter operation, advanced avionics, the TriStar failed to achieve commercial success on the same scale. It became a textbook case of how market forces, bad timing, and politics can override pure engineering brilliance. Today, fewer than a dozen L-1011s remain airworthy, often operated for niche missions like satellite launches or cargo hauling. Yet, among aviation buffs, it holds a near-mythic status, a machine that flew decades ahead of its time. The L-1011 story didn't begin on the runway. It began in boardrooms and wind tunnels. In the mid-1960s, airlines were clamoring for larger, more efficient aircraft to meet the exploding demand of the jet age. Boeing had the 747 in development, a behemoth for transoceanic travel. But airlines also needed something smaller, faster to board, and capable of servicing medium to long-range routes efficiently. This was the sweet spot, the wide-body trijet niche. And both Lockheed and McDonnell Douglas wanted in. Lockheed, primarily a military contractor at the time, hadn't produced a commercial airliner since the Electra turboprop in the 1950s. But its engineers were hungry to re-enter the civilian market. The result? The L-1011 TriStar, designed from the outset to be the most advanced airliner in the world. One of the earliest and ultimately fateful decisions was to use the Rolls-Royce RB-211 engine, a triple-spool turbofan that promised unprecedented efficiency and power. The engine was revolutionary but also underdeveloped. As Rolls-Royce fell behind in development and eventually went bankrupt in 1971, Lockheed found itself at the mercy of both British and American governments to keep the program alive. Congress had to authorize loan guarantees for Lockheed, while the UK nationalized Rolls-Royce just to keep the RB-211 alive. Despite these financial nightmares, Lockheed pressed on. The L-1011 was built with bleeding-edge technology. Its flight control systems included a centralized automatic flight control system, essentially an early version of modern flight management systems. It had triple redundancy in nearly every major system. Cabin pressurization, environmental controls, and structural materials were all designed with safety and reliability in mind. Manufacturing was also complex. The center fuselage was built in Palmdale, California. The wings came from Burbank. The RB-211 engines had to be flown in from Derby, England. This global assembly line stretched logistics to the limit. But what emerged was a jet that, on paper, outclassed everything in its category. Still, the damage had been done. The DC-10, with simpler engines and fewer delays, beat the TriStar to market by over a year. By the time the L-1011 was finally certified and flying with Eastern Airlines in 1972, many airlines had already committed to its rival. Despite everything stacked against it, Lockheed's engineers still delivered a machine that would earn the trust and admiration of those who flew and maintained it. The L-1011 TriStar wasn't just a trijet, it was a triumph of aerodynamic precision. Lockheed, with its deep roots in military aviation, poured its aerospace DNA into the TriStar's contours. While most commercial jets of the era focused on capacity and cost efficiency, the L-1011 was engineered to fly like a high-performance machine, balancing speed, efficiency, and control. The aircraft's fuselage was remarkably clean aerodynamically. The wide-body cross-section featured minimal drag-inducing protrusions, and Lockheed integrated its systems and fairings to keep airflow smooth. But what truly set the TriStar apart was its unique engine arrangement. All three engines were Rolls-Royce RB-211s, but it was the S-duct configuration of the tail-mounted engine that stole the show. Unlike the DC-10's straight-through tail engine, the L-1011 routed air through a curved S-duct embedded in the vertical stabilizer. This design reduced drag and improved flow uniformity, increasing efficiency and lowering noise. It was also safer in the event of an engine separation, as the duct reinforced the structure. However, this precision-engineered duct was expensive and difficult to manufacture. The T-tail design complemented this by keeping the horizontal stabilizers out of the turbulent wash from the wings and engines, improving pitch control. But it also came with a challenge: deep stall. Lockheed tackled this with aerodynamic safeguards and complex stall protection logic, making the TriStar incredibly stable in pitch, even during steep climbs or low-speed approaches. Where the TriStar truly flexed its genius was in its advanced flight control systems. Long before digital fly-by-wire, Lockheed introduced a system called Central Airplane Flight System, an analog logic network that coordinated elevator, rudder, and spoiler inputs to prevent overstressing the aircraft. The pilots didn't just fly the plane, they were backed up by an early analog smart system constantly optimizing flight control responses. Pilots frequently praised the TriStar's smooth handling, even during turbulence or crosswinds. Its trim system automatically adjusted control surfaces in flight, reducing workload and fuel burn. Add to that one of the first true autoland systems, and you had a plane that could fly itself down to the runway in near-zero visibility, unheard of in the early 1970s. If the L-1011's fuselage was a sleek body, the wings and engines were its muscle and brain. Every square foot of wing was carefully sculpted for efficiency, stability, and performance in a wide variety of flight conditions. The TriStar's wings were swept back at 35 degrees, optimizing them for high-speed cruise at Mach 0.84. The leading edge featured full-span slats, which deployed during low-speed flight to increase lift and prevent stalls. On landing, triple-slotted flaps extended from the trailing edge, an unusually complex system that greatly increased wing area and camber, allowing the aircraft to descend steeply at low speeds without losing control. Spoilers, both speed brakes and roll assist, played dual roles. Mid-span spoilers helped with lateral control and were even used in-flight for smoother roll responses. During landing, lift dump spoilers deployed automatically upon touchdown, shifting the aircraft's weight to the landing gear and enhancing braking performance. Now, let's talk about the heart of the TriStar, the Rolls-Royce RB-211 engines. This wasn't just a new engine, it was a leap in propulsion design. The RB-211 was the world's first triple-spool turbofan with 3 rotating shafts, fan, intermediate, and high pressure, spinning independently inside one housing. This allowed the engine to run far more efficiently across different altitudes and speeds, improving fuel economy, thrust control, and durability. The RB-211-22B variant, used in early TriStars, generated 42,000 pounds of thrust, while later variants like the -524B increased that to nearly 50,000. The engine's carbon fiber fan blades were ahead of their time, though they initially caused structural issues that nearly doomed the program. After redesign, the RB-211 became one of the most reliable engines in its class and served long beyond the TriStar. In fact, it powered Boeing 747s and 757s for decades. Mounting the engines was also a work of structural genius. The underwing pylons were designed to minimize vibration and aerodynamic interference, with integrated airflow smoothing inlets. The tail engine, meanwhile, required the S-duct to feed air around bends with minimal pressure loss, a complex shape that had to be hand-fabricated with tolerances tighter than most military jets. Together, the wings and engines made the TriStar remarkably fuel-efficient for its size, capable of cruising long ranges with whisper-quiet cabin noise, something passengers and crew frequently commented on. In fact, many L-1011 crews reported that engine startup and shutdown were so quiet, passengers hardly noticed. While wings and engines get the glory, the landing gear is the quiet hero of any aircraft. Lockheed's engineers gave the TriStar a robust and technically refined gear system, built for strength, smoothness, and safety on a wide range of runways around the world. The main landing gear configuration consisted of 4-wheel bogies mounted in 2 main gear assemblies under the wings and fuselage. Each bogie was equipped with oleo-pneumatic shock absorbers, which used hydraulic fluid and nitrogen gas to dampen the massive loads of touchdown. This gave the TriStar its famously smooth landings, even on rough or uneven tarmac. Pilots consistently praised the butter-soft contact the TriStar made with the runway. The nose gear, meanwhile, was a 2-wheel unit positioned slightly aft of the cockpit, with a powerful steering actuator system capable of turning the nose wheel up to 65 degrees. This gave the L-1011 excellent ground maneuverability, especially important for such a large aircraft operating in tight airport gates or making 180-degree turns on narrow taxiways. One fascinating feature of the TriStar's landing system was its automatic braking logic and anti-skid system. Similar to modern-day ABS in cars, the TriStar could detect when wheels began to lock up and modulate braking pressure accordingly, enhancing safety during wet or icy runway conditions. The auto-brake system, tied into the aircraft's auto-land function, allowed for automated rollout with controlled deceleration, which reduced pilot workload and ensured consistent stopping performance. Another point of pride was the weight distribution and landing gear retraction sequence. The gear bays were cleverly integrated into the fuselage and wing root to minimize drag, and the retraction process was choreographed with hydraulic precision. The L-1011 even had redundant gear extension systems. If the primary hydraulics failed, a pneumatic backup system could blow the gear down using compressed air. On takeoff, the L-1011 utilized its high-lift devices and thrust from the RB-211S to rotate gracefully at relatively low speeds for its size, thanks to its optimized wing loading and powerful flap configurations. Pilots appreciated the predictable rotation characteristics and the aircraft's ability to lift off smoothly from shorter runways than many of its wide-body competitors. When the L-1011 TriStar first appeared on the scene, it entered a three-way dogfight for dominance in the wide-body, long-haul airliner market. Its two main rivals were the McDonnell Douglas DC-10 and the Airbus A300, with the Boeing 747 SP occasionally competing on long-haul routes. On paper, the TriStar beat most of them outright, but the market told a different story. Let's start with the DC-10, the TriStar's most direct competitor. Both were tri-jets, carried similar passenger loads, and were built for medium to long-haul flights. But while the DC-10 made it to market first, the TriStar was technically more advanced in nearly every category. It had better redundancy in hydraulic systems, more advanced avionics, and a certified auto-land system that the DC-10 lacked for years. The RB-211 engines were quieter and more fuel-efficient than the DC-10's General Electric CF6 engines. Structurally, the L-1011 was built with fail-safe load paths, meaning even if a section of fuselage or wing experienced a failure, the load would be redistributed. After the infamous DC-10 cargo door disaster in 1974, the TriStar's reputation for safety stood out. It never suffered a catastrophic hull loss due to design flaws. Statistically, the L-1011 became one of the safest wide-body aircraft ever built. Then there was the Airbus A300, a wide-body twin-jet. The A300 was lighter, cheaper, and more fuel-efficient on short to medium routes, and it benefited from twin-engine certification over land. It couldn't match the TriStar's range or payload flexibility, but it found a niche in regional long-haul and quickly gained traction, especially in Europe and Asia. The Boeing 747 SP, though in a slightly different category, offered ultra-long range and high capacity. But it came at the cost of efficiency and was expensive to operate for routes the TriStar could handle with better fuel economy and fewer passengers. So why did the L-1011 lose? 3 reasons: timing, economics, and politics. The Rolls-Royce bankruptcy delayed production and shook airline confidence. The DC-10 swooped in early and secured key contracts, while Lockheed struggled to recoup its development costs. The A300 undercut it on price, and ultimately, Lockheed's decision to withdraw from commercial aviation in the early 1980s meant no long-term support or development path for the TriStar. Yet among those who flew and maintained it, the verdict is unanimous. The L-1011 was the best aircraft of its kind. It flew with elegance, protected its passengers with care, and whispered through the skies while others roared. It was Lockheed's tri-jet dream: too advanced, too expensive, and too early.